This is a bit of a technical lesson in that we're looking at some of the words that we use in maths and trying to be a bit more official, I suppose, whenever we're speaking them. So an expression is a collection of numbers and letters with no equal sign. So a lot of time people will talk about an equation, this and an equation that. But if we just have a series of terms like 5 or 2x or a plus b or 2 upon x plus 1, those are just expressions because they are terms without an equal sign. Whereas an equation is whenever one expression is put against another. So 7x plus 4, that would be an expression all on its own, as would 2. But because one expression is equal to another, then it's now an equation. Similarly, 2y and 8 are expressions, but because they're being equated, then it's an equation. And x plus y and 10, they again are expressions, but because of the equal sign, that turns into an equation. A formula is very similar to an equation, only in that the letters or the variables that are linked actually stand for something. So when a equals pi r squared, the a represents area and the r represents the radius. In v equals L times b times h, you've got the volume is equal to the length times the breadth times the height. So they stand for something. Or again, you could have an nth term, could equal 2m plus 4. But essentially you've got one variable is being related to the other. So that is a formula. An identity is an expression where each part is identically equal to. So for any value of the x value, it is true. So in 7x plus 4 equals 2, that is only true for one particular value of x. Similar for x plus y equals 10, there are different values for which that's true. But an identity, both sides must be true for every single value of x. So the way we do that is by looking at the coefficients. Now the coefficient of something is just the number before it. So in negative 2x squared, the coefficient is negative 2. In x cubed, the coefficient is 1 because there's one of them. And the coefficients must be the same throughout. So if we had an expression where we had 2x cubed is identically equal to ax cubed, then a must equal 2, and that has to be true for it to be identically equal to. So in this example, if 2x squared plus 3x plus 4 is identically equal to ax squared plus bx plus 4, that means if we were to look at the x squareds, so on the left we have 2x squared, and on the right we have ax squared. So if they are identically equal, that means that 2 must equal a. If we look at the x terms, we have 3x on the left, and that needs to be identically equal to bx, so then b must equal 3. And in the number terms, what we have is 4 is identically equal to 4. So, well, that's standard enough. 4 does equal 4 for all values. So what we have for these two identities, or these two expressions to be identically equal, then a must equal 2 and b must equal 3. In this example, for the left-hand side to be identically equal to the right, what we've got is a bracket being squared. Now we've looked at that previously, and if we have a bracket being squared, that must mean it's the bracket multiplied by itself. So if we write this out as a plus x multiplied by a plus x, or x plus a, sorry, and using our FOIL method, where the first are being multiplied together, and the outer, and the inner, and the last, what we get is x squared plus ax plus ax plus a squared, and then we still have this minus 5, and that needs to be identically equal to x squared plus bx plus 11. Now we can simplify the left hand side. We've got x squared plus 2ax, so ax plus ax is 2ax, plus a squared minus 5, and that must be the same as x squared plus bx plus 11. So if we were to look at the x squared terms, on the left of the identity we've got x squared, and on the right we've got x squared. So what we're saying is that x squared is exactly the same as x squared, which we know that's right. For the x terms then, on the left hand side, the only thing with the x is this 2ax, and that has to be the same then as the x term on the right, which is bx. And what we have there is that can be simplified down to 2a is equal to b. Now, we don't know anything about a and b, so that's as far as we can go at the minute. Then if we look at the numbers, on the left-hand side, now the numbers are all the terms without an x. So on the left-hand side, what we have is an a squared minus 5. And on the right, we've got an 11. So what that means is that a squared minus 5 must equal 11. And if that's true, if we add 5 to both sides, we get a squared equals 16. So then a must equal the plus or minus square root of 16, which is plus or minus 4. Now what we have is that we now have two values of a, so a can be positive 4 or a can be minus 4. And what we know is that b is equal to 2a. So if a is positive 4, b is going to be double it, which is positive 8. Or if it was negative 4, b would then be negative 8. So in the cases where a is equal to 4 and b equals 8, or a equals minus 4 and b equals minus 8, then the two expressions must be exactly the same. Therefore we have an identity.